Simulation and testing plays a vital role in engineering solutions for the automotive industry. To throw more light on the same, may I please request Head Multiphysics Group, Siemens India, Sridhar Hari to kindly step on stage and address our audience.
Thank you. A very good afternoon to each one of you. I think it's getting to the end of the session, so everybody is in a hurry to leave. So I'll just quickly breeze through the slides here. I also have to go to catch a flight in a short time from now. So the global drive is Paris Agreement, emission standards. The way to go about addressing this lies with two important things. One is innovation, the other one is electrification. And these are the two themes which we'll think about in the next 10 minutes. So this is a very famous quote that's very appropriate to the content here. One of the things that this makes is the fact that most of the Fortune 500 companies that went out of business did so because they failed to innovate. And what we mean by innovation within the Siemens context is a concept called as digitization, which consists of three phases. First one is ideation, second one is realization, and the third one is utilization. So ideation is the front end, as one of the speakers was talking about, all the research and development activities that are in the first phase of the design process. Realization is the second phase, wherein a product is made from the ideals, and all the processes that go from the ideal to the product are digitized. And the utilization phase is the last one, where once it's put on the road till its end of the life, every process that goes towards analysis and correction is digitized. So if we are at a place when we can get all these things, three things together, we get what is called as a holistic digital twin. And this is exactly what Siemens has envisioned this 20 years ago. And today we have a sim center, which our company has put together a suite of tools, 1D tools, 3D tools, data acquisition and analysis tools, as well as tools towards optimizations. So all of them under one roof that are available under the sim center framework. So what I'll do in the next few minutes is to quickly walk you through the usage of each of these tools as it pertains to different applications. So I'll start with showing the first part of it is actually electrification. And within the Siemens framework, we have these tools that we have listed up here. Battery Design Studio, Battery Simulation Module, Star CCM Plus, and Emission. Each one of these tools can help you do simulations that go all the way from doing microstructure simulations at micro levels in an electrode, all the way towards doing simulations on a system level using the Emission and a combination of things like BDS, BSM, and then Emission in the same simulation towards analyzing the system and local responses. So this is an example where the system and local responses is combined together, and a multidisciplinary optimization tool called as HEATS is pitched in here to make a very compact electrification part. And we are able to also use the HEATS platform to make sure that the compact part is cooled well along with the other systems. In this performance, in this slide, what we are showing is again the same tool that we talked about, HEATS. Unlike the previous one where there was a geometric modification that was involved, what we show here is how the HEATS tool basically talks with many different 1D tools that are available in the problem, as well as regulates the flow that goes into the battery pack to cool it and to the passenger comfort region. And this is a slightly different simulation, wherein we've used HEATS to have two contradicting objectives. One is minimizing drag, and second one is improved cooling without compromising on the minimized drag. So HEATS here involves doing design optimization of the grill front intake region, and as well at the same time, HEATS is also used towards optimizing the radiation fan that helps towards battery cooling. So these two objectives competing objectives can be combined under the same framework, and HEATS can give us a solution to address such type of things. So this is a, next 3 slides will be actually from testimonials from our customers. Indesa is one of our channel partners at Germany that has used a combination of 1D and 3D tools that we have in our putty that actually goes towards doing the engine simulations with the engine alone, a 3D simulation, and the rest of the systems that comprise the front part as 1D simulation. And within the HEATS framework, we can do a concept called as co-simulation, wherein the 1D and the 3D things can be separately done, and the information exchange can happen as and when you decide it to happen. So this demonstrates such a thing. So at the end of the day, you'll get a mapping of the temperature of the different parts of the engine part. So this is a Daimler testimonial where they have used a combination of Star CCM Plus tool, that is a 3D tool, to provide aeroacoustics. This goes actually towards understanding how to minimize noise inside the cabin. The noise has 2 sources, one from the bottom and one from the top. So the aeroacoustics part, that is the source for the noise, is captured using Star CCM Plus, and then you use a vibroacoustic tool called as VL, that is actually a Siemens product, to take that signal from the aeroacoustics and then propagating it through the structure to address the problem of noise inside the cabin. So in this case, you can see that validation of both the experimental part and the simulation part is actually shown. So here is another example from John Deere. This example talks about fatigue for the operator that sits inside the tractor there. The tractor is very highly automized and well protected by sound, but still when the tractor was run on highways at high speeds, there was fatigue and there are high frequency noises that are noticed. So here John Deere actually approached our Siemens engineering services team that took up this problem, did the wind testing, and were able to reproduce the sound that was found in the road. And once they were able to do wind testing and identify the problem, they used a simulation using our aeroacoustics tools to reproduce that wind testing noise. And once they were able to do that and prove that from simulation we can be able to capture the same noise, then they started doing design modifications of the domain to make sure that that noise will be suppressed. So this is an example where we can also provide services as a front end to prepare the customer to be able to do simulations at a later stage. And so I really concluded very fast. It basically is the last slide. It basically tells that SimCenter has all the combination of 1D tools, 3D tools, optimization tools, data analysis, and manufacturing tools that can talk among themselves to help the industry with doing the different types of problems that we are at this stage, both from the innovation perspective as well as from the electrification perspective. And thank you very much for your attention.